Hey coders, welcome back to the final round STE. So in the previous videos, we learnt about the singleton design pattern and its implementation, which is eager loading, lazy loading, and how to make it thread safe. But have you ever heard of Bill Pugh Singleton? If not, then let me tell you, it is the ninja of all singleton patterns. It is thread safe, efficient, and lazy. Today we'll break it down step by step, we'll compare it with other implementations and see why it is the best. So let's dive in. We'll start with why do we need Bill Pugh Singleton and what flaws do we have with the traditional methods like eager initialization. Now what happens is in eager initialization it is that we create the instances upfront. What if we are not using the created instances? Then it is a wastage of memory, isn't it? Whereas if we are doing it lazy way, if we are using synchronized, it is thread safe but it is slow. So enter the Bill Pugh Singleton, which is best of the both worlds. It implements JVM locks, which is fast as compared to the sync threads, which are slow. Let us deep dive into the coding part of it. We'll start with making a constructor out of it. What do we want? We want the constructor to be private, as we have already done it earlier. Why? Because we don't want each and every class to be using its instances. The other part, we want the JVM to handle it, correct? So what we will do is we'll create a private static inner class. This private static class will return us the singleton instance. Let us call this class inner call singleton. Now in this particular class will have a variable which would be returning us the instance of the singleton method. We'll be having this final and static. It will return a singleton, so the data type would be singleton, and let's name it instance. What it will do, it is creating the new instance for us. Now the epic part of it, how do we call it? We'll require a public method. Why a public? So that each and every class can call it. Public static, and the data type, return type would be singleton again because it is returning us the instance of the singleton class, and then get instance method. What it is doing, it is returning the inner class singleton ka instance variable. Let us save and compile if it is running fine. So it is compiled errorlessly and running it, it is giving us true. That is the first time we are calling singleton, it is creating an instance out of it. The second time what it does is it returns the same instance. Now how does it do it? So here's the trick. The inner static class, it doesn't load until the getInstance method is called. Correct. And JVM, the class loading ensures the thread safety. But how? So JVM loads the class lazily. When it encounters main method, it goes into calling the getInstance method. When the first getInstance method is called, it creates an instance out of it. This is how it implements a lazy loading. Now the inner static class, it isn't loaded till getInstance is called. Correct. It is a lazy approach. What it does, JVM acquires the lock internally when the first thread is executing. When the first thread is calling getInstance, it acquires the lock internally. It initializes the instance variable and then only releases the lock. The lock is on the class basis, per class basis. It has a method class called CLINIT, CL init. What this method is doing, it is an atomic method and only one thread can execute it. Okay, so whenever the first thread is going in, JVM is initializing the CL init method. The method being atomic, it creates a lock on the instance variable, it generates it. But when the following subsequent threads are trying to access the instance variable, they are skipping the CL init method. Hence, they're not again and again calling the new singleton method. It is all what JVM is doing internally. We are not having any kind of synchronization or the blocking parts on it. This is how the Bill plugs pattern implementation works. And it is faster because it does not use the synchronized word, and it is not even eager loaded, so even our memory is kept optimized. Thank you so much. Please like, follow for more such videos, and please let me know your reviews about it. Thank you.